Hello guys, welcome back to the channel. So in this video also we will continue our chapter, that is Inverse Laplace Transform. And today we are going to see how to solve Laplace transform of this type using the method of partial fractions. So suppose if they ask you to find out Laplace inverse of s plus 2 upon s square into s plus 3. So we have to find out Laplace inverse of the given function of s. Here phi of s is equal to what? S plus 2 upon s square into s plus 3. Now we will use the method of partial fractions. So we know that we can write this given function as a upon s plus b upon s square plus c upon s plus 3 using partial fractions. So these are nothing but constants. So we have to find out the values of a, b and c. So now the LCM of s square and s plus 3 is s square into s plus 3. Now from here we will get a s into s plus 3. Here we will get b into s plus 3, and here we will get plus c into s square. Now here we have s plus 2 upon s square into s plus 3, so this denominator gets cancelled. Now we will get s plus 2 is equal to, now let's solve the bracket. So as into s will become as square plus 3as plus bs plus 3b plus cs square. Now the next step will be we have to take this s square common. So we will get a plus c. Now we will take s common. So we will get 3a plus b. Now what is the remaining part? That is 3b. We will write as it is. Now here we have s plus 2 and here we have this right hand side. Now you have to compare both the sides. So you will get here the coefficient of s square is nothing but 0. So from this we will get, by comparing both sides, we get a plus c is equal to 0 because here there isn't any coefficient of s square. Here 3a plus b, so coefficient of s is here 1 is equal to 1. Now the remaining part, that is 3b, is equal to, from LHS we will get 2. So b is nothing but 2 by 3. If we substitute the value of b here, we will get 3a is equal to 1 minus, if b comes right hand side it will become minus 2 by 3. So 3a is equal to what? 1 by 3. That is 3 1s are 3, minus 2 is 1 upon 3. So a is equal to 1 upon 9. And from this equation we will get c is equal to minus 1 by 9. So that's how we have found out the value of a, b and c by comparing both the sides. So now see this step here. Phi of s is equal to a upon s plus b upon s square plus c upon s plus 3. And we have to find the Laplace inverse or inverse Laplace of phi upon s. So inverse Laplace of phi upon s, that is s plus 2 upon s square into s plus 3 is equal to a upon s. We have a is equal to 1 upon 9. So 1 upon 9 into Laplace inverse of 1 upon s. A is constant, that's why I have right outside the bracket, plus b, that is 2 by 3 upon s square. B is constant, that's why we have to write it outside the bracket. So what is the remaining part? 1 upon s square. Now the next is plus c. Here c is minus 1 by 9. So minus 1 by 9. What is the remaining part? 1 upon s plus 3. That is Laplace inverse of 1 upon s plus 3. Now let us use the list of Laplace transform, inverse Laplace transform. So we get 1 upon 9 into inverse Laplace of 1 upon s is 1 plus 2 by 3 into inverse Laplace of 1 upon s square. So here n is integer, that is 2 is integer. So we will use this formula, that is t raised to n minus 1. So t raised to 2 minus 1 is 1 upon n minus 1 factorial, that is 2 minus 1 factorial is 1. So we will get 2 by 3 into t minus 1 upon 9. Here we have the formula for 1 upon s, but this plus 3 is extra part. So in the previous video we have seen the shifting theorem. So we will use the theorem. So according to the shifting theorem we will get e raised to, if it is plus we will get minus 3t into Laplace inverse of, now except this plus 3 part, what is the remaining part? 1 upon s. So this is the application of shifting theorem. Now the final answer is 1 upon 9 into 1 is 1 upon 9 plus 2 by 3t minus 1 upon 9 e raised to minus 3t. So answer of 1 upon s, inverse Laplace of 1 upon s is 1. So this is the final answer. So that's how we will use the method of partial fraction to find out the Laplace inverse or inverse Laplace of this given type of numericals. Now let us see another example. So we have an example, that is you have to find out inverse Laplace transform of s plus 29 upon s plus 4 into s square plus 9. Here also we will use the method of partial fractions. So we have phi of s is equal to s plus 29 upon s plus 4 into s square plus 9. Here the fractions are a upon s plus 4 and plus ps plus c upon s square plus 9. Now we will do the cross multiplication. So we have the denominator s plus 4 s square plus 9. So by cross multiplication a into s square plus 9 and here plus bs plus c into s plus 4. Now here this denominator gets cancelled. So we will write s plus 29 is equal to, now let's solve the bracket, as square plus 9a plus, now bs into s is bs square, then bs into 4 is 4bs, then c into s, then c into 4, that is 4c. Now let's take this s square common, so we will get a plus b. Now let's take s common, so we will get 4b plus c. Now what is the remaining part? That is 4a plus 4c, sorry 9a plus 4c, and here we have s plus 29. So if you compare the both sides, so here the coefficient of s square is 0, so we will get a plus b is equal to 0. Now see the coefficient of s, here it is 1, so 4b plus c is equal to 1. The remaining part, that is 9a plus 4c, we will get is equal to what? 29 from the left hand side. So now see this, here a plus b is equal to 0, so a is nothing but minus b. Now substitute this, a is equal to minus b here, so this 4b will become minus 4a plus c is equal to 1. Now if you multiply this equation by 4, you will get what? 4 4s are 16. So I will write from this equation, that is multiplying with 4. So you will get 4 into minus 4a will become minus 16a plus 4 into c, 4c is equal to 4 into 1, 4. Now if you subtract this equation from this equation, you will get what? This minus will become plus, this plus will become minus, and here also it will become minus. So plus 16a plus 9a will become 25a. 4c gets cancelled, is equal to 29 minus 4 is 25. So a is equal to 1. Now substitute this a is equal to 1 in this equation, so you will get minus 4, so a is 1, so minus 4 into 1 plus c is equal to 1. So minus 4 into 1 is minus 4, so if it comes at the right hand side, it will become plus 4. So 1 plus 4 is 5, so c is equal to 5. Now if a is equal to 1, b is equal to what? Minus 1 from this equation, b is equal to minus 1. So you will get the values of a, b, c by comparing both sides and solving it simultaneously. Now see this step. We will get the Laplace inverse of phi of s, that is s plus 29 upon s plus 4 into s square plus 9 is equal to a upon Laplace transform of 1 upon s plus 4, as a is constant. So a is constant. Here a का value कितना है? A is equal to 1. So we will get 1 into Laplace inverse of 1 upon s plus 4. Next, plus b plus c. So inverse Laplace of b. What is b? B is minus 1. So minus 1 into s will become minus s plus c. C is 5. So plus 5 upon s square plus 9. So now let's write this step as 1 upon s plus 4. Now let's split the numerator. So we will get minus s, that is minus Laplace transform of s upon s square plus 9. S upon s square plus 9. This minus I will write here. So this plus will become minus. Next, plus 5 is constant, and in the bracket we have inverse Laplace of 5 upon s square plus 9. So 5 I will write here, and the remaining part I will write here. So now we have the formula for these functions. So we have the formula for 1 upon s. See, this inverse Laplace of 1 upon s is 1. But here this plus 4 is extra part. So we will use shifting theorem. So by the shifting theorem we will get e raised to minus bt, right? Here plus. So we will write in the power minus. So plus 4 will become minus 4t here into Laplace inverse of, except this plus 4, the remaining part is 1 upon s, as we have learned in the first lecture of inverse Laplace transform. So now inverse Laplace transform of 1 upon s is 1. So we will get only e raised to minus 4t. Now we have the formula for Laplace inverse of s upon s square plus 9, that is s upon s square plus a square, that is cos at. Here a is 3 square is 9, so a is 3. So we will write cos at, that is minus cos 3t. And the next step is plus 5. Let us write this 5 as it is, because it is constant. Now we have the formula for Laplace inverse of 1 upon s square plus a square, that is 1 by a sin at. Here a is 3 square is 9, so a is 3. So according to the formula 1 upon a, so 1 upon a is 3 sin at, sin 3t. This is your final answer of the given numerical. That's all for today. In today's lecture we have seen how to solve the given type of examples using method of partial fractions. We will continue our chapter, that is inverse Laplace transform, in the next videos. Thank you very much for watching.